We have spent the last decade treating Kubernetes as the final destination of our cloud journey, but if you are still handcrafting YAML manifests and manually managing cluster upgrades as we approach 2026, you have already lost the competitive edge. Kelsey Hightower, the very visionary who evangelized Kubernetes to the masses, recently shook the foundations of the cloud-native world. He argued that the goal was never to make every developer a Kubernetes expert, but to make Kubernetes invisible. For years, we have forced application engineers to understand pod specs, ingress controllers, and sidecar patterns, effectively turning our high-value software engineers into junior SREs. This leakage of infrastructure concerns into the application layer is the primary reason why so many digital transformation projects stall and fail to deliver ROI. By 2026, direct interaction with the Kubernetes API will be viewed as a low-level activity, much like writing assembly code is today. We are moving toward a world where the platform absorbs the complexity, leaving the developer with only the intent of their code. But wait, if Kubernetes Era is ending, what exactly replaces it? By the end of this lecture, you will see why the death of direct Kubernetes management is actually the birth of true engineering productivity. Why is this shift happening now? It is because we have reached the absolute peak of cognitive load. In the early days of DevOps, we preached you build it, you run it. But in our rush to automate everything, we handed developers a massive toolbox of 1,000 CNCF projects and told them to figure it out. This resulted in what we now call developer burnout. A typical engineer today has to juggle Docker files, Helm charts, Terraform scripts, and Prometheus alerts before they can even write a single line of business logic. In real-world environments, this fragmentation leads to shadow ops, where small teams build their own bespoke, unmanaged scripts just to survive the day. The infrastructure has become so noisy that the actual product value is being lost in a sea of configuration files. We are seeing a critical tipping point where the cost of managing the platform exceeds the value of the software running on it. This is not just a technical hurdle. It is a strategic failure of modern IT architecture. Is there a way to simplify this without losing the power of the cloud? The answer lies in how we redefine the boundary between the application and the infrastructure. But this transition isn't as simple as just buying a new tool. It requires a complete cultural shift in how we view the role of the operator. So, where do we go from here? The path forward is not about abandoning Kubernetes, but about evolving our relationship with it. We are entering the era of platform engineering, where the infrastructure team stops being a ticket processing unit and starts being a product team. Your internal platform is your product, and the developers are your customers. By 2026, successful organizations will be those that provide an internal developer platform (IDP) that offers a golden path, a paved road that makes the right way the easy way. This lecture will guide you through this transition, moving from managing clusters to managing outcomes. We will analyze how to build abstractions that are leaky enough to be powerful, but opinionated enough to be simple. We will look at real-world benchmarks where teams reduced onboarding time from weeks to minutes by hiding the very Kubernetes features we once fought so hard to learn. This shift requires a fundamental change in your team's DNA, moving away from reactive firefighting toward proactive product development. But is an IDP just another layer of complexity, or is it the ultimate cure for the DevOps hangover? In the next chapter, we will dive deep into the specific evolution from traditional DevOps to the new era of platform engineering to find out. The DevOps movement began with a revolutionary promise: you build it, you run it. It was intended to shatter the silos between developers and operations. However, the reality of 2024 tells a different story. In most organizations, we didn't actually merge the roles. We simply dumped the cognitive load of complex infrastructure onto developers who just wanted to write business logic. This Noops dream turned into a nightmare, where developers spend 40% of their time debugging YAML files and ingress controllers instead of shipping features. We mistakenly equated DevOps with devs doing ops work without the necessary expertise. This fundamental misunderstanding of the original philosophy created a massive gap between expectations and production reality. Is the culture broken, or did we just give them too much complexity to handle? Let's look at the specific technical wall everyone is hitting right now. But wait, there's a reason why even the most senior developers are currently drowning in configuration files. This burden has a specific name, and it's the very reason your current platform is likely to fail by 2026. Kelsey Hightower famously said that Kubernetes is a platform for building platforms, not an end-user product. Yet, many teams treat raw K8s as the final interface for their developers. This is what we call YAML hell. In this environment, a developer needs to understand deployment specs, service meshes, and pod disruption budgets just to deploy a simple Hello World app. On the other hand, the invisible infrastructure ideal focuses on abstraction. In this model, the infrastructure exists, but it is felt only through its reliability and performance, not its complexity. Think about the shift from managing servers to using high-level abstractions where the platform handles the complexity under the hood. If your developers are still manually writing 500 lines of K8s manifest files, you haven't built a platform. You've just outsourced your ops burden to your most expensive employees. But how do we bridge this gap without losing control? The answer lies in a specific organizational shift that separates reliability from enablement. This distinction is exactly where many companies get confused, leading to massive internal friction. To understand the path forward, we must distinguish between site reliability engineering, SRE, and platform engineering. While they share common ground, their primary objectives differ significantly. SRE is fundamentally about the product of the company ensuring that the external service is reliable, scalable, and meets SLOs. Platform engineering, conversely, is about the internal product ensuring that the internal developers can ship code faster and more safely. If SRE is the guardian of the production environment, the platform engineer is the architect of the developer's journey. By 2026, successful organizations won't just have an ops team, they will have a platform team that treats developers as their customers. This is not just a semantic change, it's a structural pivot that changes how we measure success. But treating developers as customers is harder than it sounds. It requires a mindset shift that most infrastructure veterans struggle with. What happens when your internal customers hate the platform you built? We're about to dive into the philosophy that prevents this exact disaster. The core shift in platform engineering is adopting a product mindset. In the old world, infrastructure teams were ticket takers. You ask for a database, and they give it to you in 3 days. In the new world, the platform team must act as product managers. This means identifying the pain points of your internal developers through actual interviews and feedback loops. You aren't just building a Kubernetes cluster, you are building a product that solves the problem of how do I get my code to production safely. This requires a continuous feedback loop. If a developer finds your deployment process frustrating, that is a bug in your platform product. By treating developers as customers, you move away from dictating tools and toward enabling outcomes. This philosophy ensures that you don't build features that no one uses. But how do you provide this ease of use without creating a Wild West where every developer does something different? This is where the concept of paved roads comes into play, and it's the secret to scaling platform success. To balance developer freedom with operational stability, we use golden paths. A golden path is a pre-approved, automated, and supported way to build and deploy software. If a developer stays on the golden path, they get everything for free. CI/CD, logging, monitoring, and security scanning are all baked in. It's the path of least resistance. However, platform engineering isn't about building golden cages. Developers should still have the freedom to go off the path if they have a unique requirement, but they then take on the operational burden themselves. This self-service model with guardrails is what Kelsey Hightower advocates for. It allows the platform team to enforce security standards through code, policy as code, rather than through manual ticket approvals. This ensures that the platform is both flexible and secure by design. Now, you might wonder, how do we actually measure if this is working? We need metrics that go beyond just up or down. We need to measure the human element of engineering. In the evolution of DevOps to platform engineering, developer experience, DX, becomes the primary KPI. We no longer just care about CPU usage. We care about time to hello world. How long does it take a new engineer to get their first line of code into production? If it takes 2 weeks because of access requests and manual configurations, your platform is failing. We look at metrics like deployment frequency and lead time for changes, but we also look at qualitative developer satisfaction scores. By 2026, the success of an infrastructure team will be judged by how much they disappear into the background. A great platform is like high-quality plumbing. You only notice it when it's broken, but otherwise, it just enables everything else to function perfectly. We've traced evolution from the failure of DevOps to the rise of the platform as a product. But what does the actual architecture of these 2026 platforms look like? In the next chapter, we will break down the specific components from IDPs to cross-plane that make this invisible infrastructure a reality. Many engineering teams fall into the trap of thinking that installing Backstage or a similar UI tool means they have successfully built a platform. In reality, a portal is merely the glass through which developers interact with a much deeper system. By 2026, the architecture of a true internal developer portal must solve the cognitive load problem by abstracting the complexities of Kubernetes and cloud providers. Tools like Port and Humanitech are gaining traction because they don't just provide a dashboard, they provide a blueprint for a service's entire lifecycle. We are moving away from fragmented scripts toward a unified interface that manages documentation, service health, and deployment status in one place. However, if your underlying infrastructure lacks standardization, your fancy UI will eventually become a graveyard of broken links and outdated configurations. The real challenge isn't the front end, but the integration layer that connects these portals to your actual production environment. Question: does your portal actually empower developers, or is it just another bureaucratic layer they have to click through? Let's look at the engine beneath the hood. The most significant architectural shift in 2026 is the rise of the platform orchestrator. Unlike a simple CI/CD pipeline that pushes code to a cluster, an orchestrator interprets a high-level workload specification such as the score specification and determines what infrastructure is needed based on the target environment. Imagine a developer declaring, "I need a database and a cache," without specifying if it's an RDS instance or a local container. The orchestrator evaluates the context, be it development, staging, or production, and automatically provisions the correct resources according to the organization's standards. This separation of concerns allows developers to focus on the while the platform team defines the how through dynamic configuration management. It eliminates the need for developers to maintain thousands of lines of duplicated Helm charts or Terraform modules across different repositories. Payoff: this isn't just automation, it's the intelligent mapping of application needs to infrastructure reality. A common mistake in early DevOps was creating rigid automation that became a bottleneck as the organization grew. In 2026, the architecture favors flexible abstraction over rigid scripting. We achieve this through policy as code. Instead of blocking developers with manual approvals, the platform provides guardrails that are automatically enforced. By using tools like OPA, Open Policy Agent, or Kyverno, you can ensure that every deployment meets security and cost standards before it ever hits the cluster. This allows for standardization without stagnation. You want to provide a golden path that is so easy to use that developers naturally gravitate toward it, but you must also allow for golden escape as documented ways for advanced teams to deviate when they have unique requirements. Teaser, but how do we actually write this infrastructure intent in a way that doesn't look like a mess of YAML? Let's look at the transition to high-level declarations. Infrastructure declaration is shifting from low-level resource management to high-level intent. While Terraform is still vital for foundational setup, the 2026 platform uses tools like Crossplane to manage the cloud as if it were part of the Kubernetes API. This allows us to use composition to bundle complex resources into simple, custom objects. For instance, instead of a developer writing 200 lines of Terraform for an RDS instance, security groups, and IAM roles, they simply request a COSIT PostgreSQL instance resource. This object is defined by the platform team and includes all the necessary company standard tags, backup policies, and monitoring hooks by default. This change reduces the surface area for errors and ensures that every cloud resource created via the platform is compliant by design. Question: but if we give developers this much power to provision resources, how do we keep the CFO from having a heart attack? Governance is the other half of the story. Governance in 2026 is no longer a checklist that happens at the end of a project. It is baked in from the start. We call this shift-left governance. The platform architecture itself becomes the auditor. By integrating compliance checks directly into the platform's control plane, we ensure that no resource can exist unless it meets specific organizational criteria. For example, if a developer tries to provision a public S3 bucket, the platform orchestrator or an admission controller will reject the request immediately with a clear explanation. This moves the security team from being blockers who say no at the last minute to policy authors who define the rules that the platform enforces automatically. This proactive approach drastically reduces the risk of data breaches and misconfigurations that lead to downtime. Payoff: compliance becomes a byproduct of the developer's normal workflow, not an extra task they hate. Technically, this automated enforcement relies on a robust combination of RBAC and OPA. While Kubernetes RBAC handles who can do what at the API level, Open Policy Agent (OPA) allows us to define fine-grained logic for under what conditions. For example, we can allow a developer to create a deployment, but only if it includes a team owner label and does not request more than 2 CPUs. The flow is seamless. The developer submits a request to the portal, the orchestrator validates it against the Rego policy engine, and if it passes, the infrastructure is provisioned. This architecture eliminates the Wild West of manual cloud console clicks and ensures every resource has a clear owner and a valid purpose. Question: but how do we deal with the inevitable question of who is paying for all this? This is where the platform meets the financial ledger. In the 2026 platform, FinOps isn't just a monthly report for management. It's a real-time feedback loop for engineers. The architecture integrates cost visibility tools directly into the developer portal. When a developer looks at their service, they see not only the CPU usage, but also the real-time dollar cost of their infrastructure. By tagging every resource via the orchestrator, the platform can provide precise cost attribution. This cost visibility changes developer behavior far more effectively than any top-down mandate. When developers can see that a specific inefficient query is costing the company $500 a day in cloud data transfer fees, they are incentivized to optimize it. The platform enables a culture of cost awareness where efficiency is treated as a first-class citizen of engineering quality. Payoff: high-performing teams use these metrics to justify infrastructure investments or identify where to cut waste. From the perspective of an IT professional engineer, the goal of this entire architecture is long-term maintainability. We aren't just building for today's deployment. We are building a system that can be audited and updated for the next 5 years. This requires a shift in strategy, from focusing on how many tools we have to how well our data flows between them. A successful 2026 platform architecture provides a clear audit trail. Every change to the infrastructure is logged, attributed, and reversible. This level of auditability is essential for regulated industries and for any organization that wants to scale without descending into chaos. Remember, the tools will change. Kubernetes might be replaced by something else by 2030, but the architectural principles of abstraction, policy, and visibility will remain. Teaser: this vision sounds great for a tech giant, but what if you only have 5 developers? In the next chapter, we will reality check this roadmap based on your team's actual size. In the early stages of a startup with a team of 5 or fewer, building a custom internal developer platform is often a recipe for disaster. At this scale, every engineer must focus on product market fit rather than reinventing the wheel of infrastructure. Kelsey Hightower often emphasizes that no code is better than no code, and for small teams, this means embracing managed services and PaaS solutions like Vercel, Heroku, or AWS App Runner. The cognitive load of managing a production-grade Kubernetes cluster including ingress controllers, certificate managers, and persistent volume claims far outweighs the benefits of fine-grained control. Your goal is to offload the undifferentiated heavy lifting to cloud providers. If your team is spending more than 10% of its time on YAML files instead of feature code, you have already lost the efficiency race. Stick to the defaults and let the provider manage the complexity until your revenue demands otherwise. But wait, what happens when your team grows and those simple managed services start feeling like a straitjacket? Let's look at the next phase. As you scale to a team of 20, the chaos of everyone doing their own thing starts to hurt. This is where standardization becomes your primary weapon. You aren't building a full-blown platform yet, but you are creating golden paths, pre-approved templates for deployments, logging, and monitoring. Instead of manual DevOps, you transition to shared infrastructure patterns using tools like Terraform modules or simple Helm charts that encapsulate your organization's best practices. This phase is about reducing friction. If a new developer joins, they shouldn't need a PhD in infrastructure to ship their first container. You might appoint a part-time infrastructure champion to maintain these patterns, ensuring that security and compliance are baked into the shared modules. The shift here is from move fast and break things to move fast with guardrails. However, manual coordination still has its limits. How do we transform these patterns into a permanent, self-service machine for an enterprise scale? The answer lies in formalization. When your organization hits its 100+ engineers, the platform engineering team must emerge as a formal internal product team. At this scale, the platform is no longer just a set of scripts. It is a product with its own roadmap, UX, and SLAs. You treat your developers as customers. This is the stage where the internal developer portal, like Backstage, becomes essential to aggregate the vast ecosystem of microservices, documentation, and infrastructure. The platform team focuses on building the platform as a service tailored specifically to the company's internal needs, often abstracting away Kubernetes entirely for the end developer. This allows specialized SREs to handle the deep technical complexities of scaling, while feature developers can ship code within minutes. The ROI here is measured in developer velocity and mean time to recovery. If done correctly, the platform team becomes a force multiplier for the entire enterprise. But be warned, if you build this without a clear understanding of costs, you are just building an expensive hobby. Let's look at the decision matrix for the build vs buy dilemma. The decision to build or buy a platform component is the most critical architectural choice you will make in 2026. This decision matrix balances organizational maturity against the cognitive load you are willing to accept. For most small to mid-sized firms, buying, which includes using managed SaaS or open core products, is the logical choice because it minimizes maintenance debt. You only build when your requirements are so unique that they provide a direct competitive advantage, or when you've reached a scale where the cost of SaaS exceeds the cost of a dedicated engineering team. We use the ROI formula: save developer hours hourly rate minus platform maintenance cost plus initial build cost. If the result isn't significantly positive, your platform is a liability, not an asset. Many teams fail because they build out of ego rather than necessity. Is your team ready to handle the day 2 operations of a custom-built abstraction? Next, we'll examine how industry giants like Spotify navigated these exact waters without sinking. Spotify is the poster child for platform engineering, having created Backstage to solve their internal fragmentation. However, most companies misunderstand the Spotify story. They didn't just build a portal, they transformed their culture to prioritize autonomous teams through shared infrastructure. At Spotify, the platform team doesn't mandate tools. They provide such a compelling golden path that developers naturally choose it because it makes their lives easier. If your developers are avoiding your platform, it's not a technical failure, it's a product failure. Backstage succeeded because it focused on the developer experience DX'd. First, providing a single pane of glass for everything from API docs to resource monitoring. The lesson here is that software cannot fix a broken culture. If your teams are siloed and resistant to change, no amount of YAML or portals will save you. When culture and tools align, the results are staggering. Let's look at how Adobe quantified this success through efficiency benchmarks. Adobe's journey into platform engineering provides a concrete benchmark for what success looks like in a massive enterprise. By building their internal cloud platform, Adobe managed to reduce developer onboarding time from weeks to just hours. They focused on 3 key metrics: lead time for changes, deployment frequency, and change failure rate, often referred to as the DORA metrics. In their case, standardized CI/CD pipelines and automated security scanning integrated directly into the platform led to a 90% reduction in manual compliance checks. This isn't just about saving time. It's about shifting the focus of thousands of engineers from how to deploy to what to build. When you can quantify that your platform saved 50,000 engineering hours last year, the budget for the platform team becomes an easy sell to leadership. But for every Adobe, there are 10 companies that fail spectacularly. Do you know the red flags of a failing platform initiative? Let's identify them before you start your project. Most platform engineering initiatives fail not because of bad technology, but because of over-engineering and a lack of adoption. A common red flag is building in a vacuum where the platform team creates a complex system without ever talking to the developers who will use it. This leads to the mandate gap where management forces a tool that everyone hates, resulting in shadow IT and workarounds. Another failure state is yet another management abstraction, YAML, where the platform is just an extra layer of complexity over Kubernetes that doesn't actually simplify anything. If your abstraction requires developers to still understand the underlying K8s manifests, you haven't built a platform. You've built a hurdle. Watch out for feature creep trying to support every edge case instead of perfecting the 80% to use case. If you see these signs, you need to pivot immediately. Now, how do these global trends translate to the specific challenges of the Korean tech ecosystem with its unique hiring market and legacy constraints? The Korean tech landscape presents unique challenges for platform engineering. We often deal with a polarized market, a few super apps with world-class infra, and many mid-sized firms struggling with massive legacy technical debt and a severe shortage of Kubernetes experts. In Korea, the managed-first strategy is even more critical because the hiring cost for a high-level SRE is extremely high. Instead of trying to replicate the Spotify model exactly, Korean teams should focus on hybrid migration, gradually wrapping legacy VM-based workloads into the platform using tools like Crossplane to manage both on-prem and cloud resources. We must also account for local security requirements and the prevalence of private clouds in certain sectors. The goal is to build a bridge between the old and the new. Remember, a platform in 2026 isn't a trophy, it's a survival tool for talent-constrained market. But how do you actually make the final go, no-go decision? In the next and final chapter, we will provide the definitive decision framework for your 2026 strategy. Before you even touch a single line of Terraform or install Backstage, you must conduct a cold, hard audit of your current delivery pipeline. In the field, we often see teams obsessed with day 2 operations like autoscaling while forgetting that it takes a new developer 3 days just to get a local environment running. Measure your time to first commit the duration from a developer joining to their first code reaching production. Is the bottleneck the ticket-based firewall request, or is it the complexity of writing 500 lines of Helm charts? By identifying these friction points through developer surveys and telemetry, you move from building for the sake of tech to building for the sake of speed. This inventory phase is what separates successful platform engineers from those just managing another expensive layer of abstraction. But once we identify these bottlenecks, how do we fix them without breaking existing production workflows? The biggest mistake in platform adoption is the Big Bang migration. Instead, you need a platform MVP, a minimum viable product that solves exactly one critical problem for one specific team. Start with a pilot project, perhaps a low-risk internal tool, and build a golden path for it. This means providing a pre-configured template where the developer only provides the code and metadata, while the platform handles the ingress, secrets, and observability. Iterate based on direct feedback from those pilot developers. Don't force everyone onto new platform on day 1. Let the platform's efficiency sell itself. If the pilot team is shipping twice as fast with half the stress, other teams will naturally follow. This iterative approach reduces the blast radius of early architectural mistakes. However, tools are only half the battle. Who is actually going to run and evolve this new platform layer? Transitioning to platform engineering requires a fundamental shift in the ops team's mindset. We are moving from infrastructure administrators who react to tickets to software engineers who build infrastructure products. This means your team needs to master Go or Python, understand API design, and embrace product management principles. You aren't just managing servers, you are managing a product where the developers are your customers. Hiring for this is difficult, so internal upskilling is vital. Encourage your team to spend time shadowing developers to understand their daily toil. This empathy-driven engineering is what ensures the platform actually solves problems rather than adding more YAML complexity. As we look toward 2026, this human element remains a critical variable. Now that we have the people and the process, where is the technology itself actually heading in the next 2 years? By 2026, the way we interact with Kubernetes will change fundamentally through the lens of AI and LLMs. We are moving toward intent-based platforms where you no longer write thousands of lines of YAML. Instead, you describe the desired state. I need a high-availability Node.js service with 50 ms latency and an AI-driven control plane handles the underlying resource allocation, scaling policies, and security sidecars. This autopilot mode for the entire infrastructure will become the standard. The platform's job shifts from providing tools to providing outcomes. We are seeing the early stages of this with AI agents integrated into CLI tools and IDEs. This doesn't make Kubernetes irrelevant. It makes it invisible, which was Kelsey Hightower's vision all along. But with all these futuristic trends, how do you decide whether to invest now or wait for the technology to mature? As an architect, you need a clear go, no-go framework for your 2025 planning. If your team is under 20 people and you are running fewer than 10 microservices, a full-blown internal developer platform is likely overkill. Stick to managed services like AWS, AppRunner, or Vercel. However, if you are scaling past 50 engineers and struggling with inconsistent deployment patterns and config sprawl, building a thin platform layer is no longer optional. The criteria for success in 2026 isn't how many clusters you manage, but how little your developers have to think about them. Evaluate your architectural debt honestly. Are you building a platform because you need it, or because it's the current hype? This architect's verdict is the most important decision you will make this year. What is the one final takeaway that will save your career and your company's budget from the chaos trap? To wrap up this journey, your Kubernetes platform will fail by 2026 if its primary goal is just to manage Kubernetes. The survivors will be those who view the platform as a way to solve developer problems and deliver business value faster. As Kelsey Hightower famously said, focus on the application, not the infrastructure. Don't build a platform, build a solution. Engage with the community, keep your abstractions thin, and never lose sight of the end user, the developer. This concludes our deep dive into the 2026 evolution of DevOps. In the next lecture series, we will move from the why to the how, specifically looking at the actual code and implementation of an intent-based platform using Crossplane and AI agents. Thank you for staying through this strategic shift, and I'll see you in the next evolution.